Hey guys, hope everybody's doing well. This video lesson is going to be on exponent rules. We're going to use this for probably the next week and a half, and there will be moments where you will pause and go back and rewatch because we're going to chip away a little bit on each one of these topics as we go through exponent rules. So let's go ahead and share screen here, and we'll start talking about exponents in general, and then the rules that go along with it. So the first thing that I want you guys to think about, and if you have not already got these notes out, if you want to pause and print them, we're going to fill in these notes as we go. This is going to be incredibly important for you guys. So if you wanted to pause now and print them, you could. If not, you'll want to write these down in your notebook if you don't have the ability to print it. The first thing is about exponents. I want you to think of an exponent as an instruction. So exponents, for the purposes of this particular section, are going to be an instruction. They're going to be telling you to do something. Now, what it's telling you to do is going to vary based on the rule that we're working with. But I want you to think about exponents as an instruction. So the first thing we're going to talk about is, what is an exponent? Well, if I look at this particular problem here, 3 to the 5th power. The 3 is what we refer to as the base. That's the base number. And then the 5 is the exponent, or also called the power. So 3 to the 5th power. And an exponent is an instruction about what to do. Now, in this case, the 5 is an instruction to take the base and multiply it by itself that many times. So this is going to equal 3 times 3 times 3 times 3 times 3. I'm going to take that base of 3 and I'm going to multiply it by itself 5 times. Now you have to be careful. That's not going to be 15. It's not 3 times 5. It's 3 times itself 5 times. Okay. Exponential form means to write your answer using exponents. So it may give you something that's expanded out, and they want you to write it using exponents. So for example, I could give you 7 times 7 times 7 times 7. And to write that in exponential form, I have the same base multiplied by itself 4 times. So that's going to be 7 to the 4th power. And that's just writing it in exponential form. Now, we could evaluate that. We could finish it and multiply it out. But when it says write in exponential form, that's all they want you to do. Now, I can take something that's going to be a little bit more involved. What if I have a problem with multiplication with more than one base? And the bases are going to be different. Well, each base will then get its own exponent. So 8 times 8 times 8 times 8 is 8 to the 4th power times x times x times x, so that's x to the 3rd power, times y times y, so that will be y to the 2nd power. And when I have all of those touching each other at the end, anytime you have a number touching a variable, that's going to mean multiplication. So I don't need to use the dot anymore because I'm going to have all of those connected and touching each other. And we'll do a couple of examples to review these ideas. It's also super important to understand how exponents are going to be affecting negative numbers. So if I give you the first idea, it's going to be -3 in parentheses to the 4th power. Now, this idea of in parentheses is going to be important because we're going to also talk about what happens if I have -3 not in parentheses to the 4th power. There's going to be a subtle difference between how we solve those problems. In this first example, the 4 is touching the parentheses, which means it applies to both the 3 and the negative. I just wanted to make sure we're recording here. We are good. So because it applies to the 3 and the negative, this is what it means. It means -3 times -3 times -3 times -3. Well, if we go back to our integer rules from earlier in the year, this is multiplication with 4 negatives. Multiplication with 4 negatives is going to be a positive. And 3 times 3 is 9, times 3 is 27, times 3 is 81. So this answer is going to be positive 81 because I multiplied with 4 negative numbers. Now, where this differs without parentheses is this 4 only belongs to the 3. So it's going to simply be 3 times 3 times 3 times 3 with a negative weighting in front. So I'm going to take this negative and I'm going to put it in front, and it will weight for whatever I get when I multiply. So 3 times 3 times 3 times 3 is 81. And this particular answer is going to be -81 because no parentheses. All right. So what I want you to do right now, I'm going to give you a few examples that I want you to try before we move on to the next section. So the first example that I want you to try, and we're going to go example number 1, is I simply want you to take this problem here, and I want you to write it in exponential form. I then want you to, for the next example, take -2 in parentheses to the 6th power. And your final example will be to take -4 to the 3rd power, not in parentheses. So pause the video right now and solve those 3 problems, and then resume to see your answer. So now that you're back, let's go ahead and take a look at the answers. 6 times itself 4 times is 6 to the 4th power times x to the 3rd power and y to the 4th power. The second example is -2 to the 6th power in parentheses. So that's -2 times -2 times -2 times -2 times -2 times -2. There are 6 negatives there, so that answer is going to be positive. And 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 again is going to be 64. All right. And then our final one here is -4 to the 3rd power, not in parentheses. So that negative sign is going to attach to the front. And then 4 times 4 times 4. Well, 4 times 4 is 16. And 16 times 4 is going to be -64. So a couple of examples to review what we talked about for basic exponent rules. So let's go ahead and take a look at the second idea for our exponent notes. The second part for our exponent notes are going to be what to do when I have multiple terms, multiple bases, multiple exponents. There's going to be 3 basic rules, and you're going to learn some fancier terminology for this in high school. But we're going to add exponents when you are multiplying with the same base. So if I am multiplying with the same base, you're going to add exponents. And that's because, remember, an exponent is an instruction. So that instruction is going to change. So for example, if I have 3 to the 5th power times 3 to the 7th power. Same base. The instruction is to multiply it 5 times and then multiply it 7 more times. So this is going to be 3, and I'm going to add the exponents, and I get 3 to the 12th power. And that's because the instruction is increasing. The number of times I'm supposed to do something is increasing. And we're going to talk about a slight little increased level of difficulty, shall we say, when it comes to that particular problem. The second rule is you're going to subtract exponents if you are dividing with the same base. Well, typically this is going to be in a fraction bar, but you could see the division symbol. And so an example of that would be 5 to the 11th power over 5 to the 6th power. And so if I am dividing with the same base, I'm going to subtract the exponents. So this becomes 5 to the 11 minus 6, which is going to equal 5 to the 5th power. And the reason for this is because I'm basically going to be taking that instruction and I'm going to be decreasing the number of times that I have 5 multiplied by itself. And then I'm going to multiply exponents when you have an exponent inside parentheses and another one outside touching the parentheses. And so that's going to look something like this. 4 to the 3rd power raised to the 5th power. So here's your exponent on the inside of parentheses, and here's the exponent on the outside touching it. So this is going to be 4, and I'm now going to multiply those two exponents, which is going to equal 4 to the 15th power. Now there are going to be some special case scenarios with all of these. What happens if you're multiplying exponents and one of the exponents is 0? Well, anything times 0 is 0. What happens if I have negative exponents? And that's something we'll explore as we go through. All right. So let's go ahead and put a couple more examples in here for you. So let's go example, example, example. So I'm going to give you 3 examples. So go ahead and pause this for a moment. Solve these 3 problems. Look back at your notes if you need to figure out which rule you're using. Now that we're back, let's take a look at these 3 example problems. This first example problem is the same base in a fraction bar, and that means division. So remember your notes. If I'm dividing the same base, I subtract the exponents. So this should become 7 to the 9th power. The second example is the same base and we're multiplying. Well, our notes told us that if we are multiplying with the same base, I'm going to add exponents. So this becomes 8 to the 16th power. And your final example is exponents inside and outside of parentheses. So we're going to multiply the 7 times the 8. And so this becomes 2 to the 56th power. So got to keep track of what you have with each one of them. Now let's take a look at some examples that are going to challenge us to think outside the box. Four to the 7th power times 4 to the negative 3rd power. We have negative exponents. I'm going to say, let's go with 11 to the 12th power divided by 11 to the negative 3rd power. We'll use the different symbol for division, and we'll put a negative in there again. And then let's go 5 to the 3rd power times, or excuse me, raised to the negative 7th power. So let's throw negative exponents in there, and then let's talk about what we need to do next. So go ahead and pause this, try all 3, and then we'll come back. Now that we're back, let's take a look at these 3 examples. This problem here is same base, and we're multiplying. Now remember your rules. Your rules said if they're the same base and we're multiplying, we add exponents. But this is going to be tricky because of integer rules. So this is going to become 4 to the 7 plus a negative 3. So I'm adding those exponents, but one of the exponents happened to be negative. Now remember our integer rules. These are different sign. So this becomes 4 to the 4th power. Now this second example is division. And our rule said that if I am dividing with the same base, I subtract. So 11 to the 12th power, subtract a negative 3. Now what happens when I have double negatives? That becomes a positive, so this becomes 11 to the 15th power. So I have to remember my exponent rules, but then I also have to remember what to do with my integers. And this one here is a power of a power. We have an exponent inside and outside, so this is going to be 5 to the 3 times negative 7. I'm going to multiply those, and that becomes 5 to the negative 21st power. Now we're going to talk very shortly about what to do with negative exponents. So this half of the exponent lesson is going to take us through week 1. So this gets us all the way through the first week of exponents. So we're going to use this video twice. I'm going to continue with the exponent rules so you have all of them in one location and you can go back. This would be a great time to pause because we're going to come back to the second portion of our integer rules next week. All right, let's continue. The next phase is going to be negative exponents. Previously in the lesson, we had the idea of negative exponents that came into play, but we don't really know what to do with them yet. We have to remember the very beginning of this exponent unit. An exponent is an instruction. Remember that, an exponent is an instruction. Well, if we come to negative exponents, what is it an instruction for? Well, a negative exponent is an instruction to send it to the other side of the fraction, essentially flipping what you see in front of you. So if we're going to look at a particular problem like that, we have to say, okay, what am I going to do when I have some of these negative exponents? So the first thing we're going to say is, okay, what if I'm already sitting in the top of a fraction, or if it's just a regular old number? So let's say, for example, I have 4 to the negative 2 power. Well, that negative exponent is an instruction to send it to the bottom because it's already sitting on the top. So this negative exponent is going to tell me, you know what, you have to send that down, which now turns it into a fraction with 4 to the second now in the bottom. So the negative exponent flips it to the bottom. Once you flip it, the exponent is now positive because you've done what the negative exponent wanted you to do. So I sent this to the bottom of a fraction, and now it's 4 to the second power, which I will evaluate as 1 over 16, because 4 squared is 4 times 4. Okay. Well, what if I have some negative exponents, but not everything is negative? So what if I have something that looks like this? 7x to the negative 5th, y to the 4th. There's one thing in that particular problem with a negative exponent, and that is the x to the 5th. So the x to the 5th is going to have to move to the bottom. Everything else will stay on top. So when I have my fraction bar, the 7 stays on top because it has an imaginary exponent. We don't see it, but there's a 1 there. The y to the 4th stays on top because it was a positive. And the x to the negative 5th flips to the bottom. And when it goes to the bottom, it becomes positive. Now, what if there's already a negative exponent that's in the bottom? So that's the second one here. If it's in the bottom, it flips to the top. So what if I have something that looks like this? 3 over x to the negative 3rd power. Well, the 3 isn't going anywhere because it already is with a positive exponent. But this guy here is now going to have to flip to the top. And then that becomes 3x to the 3rd power. All right. What if it is all a fraction? let's take this, 1/3 all to the negative second power. If you have the entire fraction inside parentheses with a negative exponent, the entire fraction has to flip. So this is going to flip from 1/3 to 3/1. And now the exponent is positive. So I will flip it, the entire fraction, and now just use the second power. So this becomes 3/1 times 3/1, which is 9/1, which is simply 9. So back here, our first example had 4 to the negative second. That became a fraction. And this one here, I already had a fraction, so it flipped, and in the end actually became just a whole number answer. So negative exponents are an instruction to flip it from the top to the bottom. And then the other piece that we're going to have is the power of 0. Anything to the power of 0 equals 1, with one exception, and that's 0 to the 0 power. 0 to the 0 power does not equal 1. That's going to be undefined. That's something that's impossible to do. And there'll be an extra credit opportunity for you guys to tell me why. So anything to the power of 0 equals 1. So 12 to the 0 power equals 1. 4,317 to the 0 power equals 1. X to the 0 power equals 1. Unless, of course, x was 0, and then it wouldn't happen. Now, pay very close attention here. -3 in parentheses to the 0 power equals 1. -3 to the 0 power not in parentheses will equal -1, because the negative sign waits for it in front. So that rule still applies even when I have something to the 0 power. Okay. So anything to the 0 power equals 1. Let's go ahead and do a couple of examples now. So let's come here to the middle of the page. Let's take 5 to the negative third power. Let's take 4x to the negative second over y to the third. And let's take 8 to the 0 power. And let's add one more difficult one. Let's go 6 to the 0 power times 3 to the negative second power. So go ahead and pause the video right now and try those 4 examples. All right, welcome back. Let's go through and see how you did on those examples here. 5 to the negative third power. Remember, a negative exponent is an instruction to flip it. Well, this is already a normal number, so this is going to flip to the bottom. So this becomes 1 over 5 to the third power, which means 1 over 125, because 5 times 5 is 25, times 5 again is 125. Example number 2. There's only one thing with a negative exponent, and that's this guy here, the x to the negative second. So 4 is going to stay on top. It's not going anywhere. You're not flipping the entire fraction. You're only flipping the piece that has a negative exponent. Y to the third is staying on the bottom. And the x to the second has to flip. And so x to the second is going to join the y to the third. I put the x to the second in front, so we have alphabetical order. 8 to the 0 power. Anything to the 0 power is 1. And now a little bit of order operations. 6 to the 0 power equals 1 times 3 to the negative second is a fraction that's going to become 1 over 3 to the second power. Well, let's evaluate that. That will be 1 times 1 over 9. And anything times 1, I'll make that 1 over 1, is going to stay 1/9. So a couple of examples here with negative exponents and the power of 0. We'll stop sharing here. And that should take you through the next section of our exponent rules. We're going to spend some time working with exponents, and we'll eventually get more complex where we start mixing these rules together, and you're going to have to keep track of what you need to use for each one. We're going to start doing our homework assignments off of IXL, and so hopefully this will make things a little bit easier for you when it comes to doing and turning in your homework. I would refer back to this lesson over and over again. If you get a little stuck on a section, rewatch it. And again, we're going to be using this for the next several sections of exponents.